Welcome to In 5 Minutes. We take problem on shear force and bending moment and we consider cantilever beam with uniformly distributed load. Our problem statement is a cantilever beam of length L is subjected to a uniformly distributed load of W per unit length. So this W is the intensity of load for a distance of L by 3 from the free end. Draw the shear force and bending moment diagram for the beam. Let's first draw a representative figure of this cantilever beam. So we have this cantilever beam which is fixed at point A and is of length L, and it is subjected to a uniformly distributed load of intensity W for a distance of L by 3 from the free end C. Let us take the unit for this intensity as Newton per meter. So for this beam we have been asked to find first the shear force diagram and second the bending moment diagram. So let's solve the problem. Before starting it, let us show the support reactions at your fixed end A. Now we know at fixed end of a cantilever beam there is a vertical support reaction which we are assuming it to be upward and denoted as VA, and also there is a supporting couple or moment acting at point A which we are assuming it to be anti-clockwise and which is denoted by MA. So our first step is to determine the support reaction and supporting couple. For that we make use of static equilibrium equation, which are summation of all moments about any point is equal to 0 and summation of all vertical forces Fy is equal to 0. So now let us apply our first static equilibrium equation at point A. So summation of all moments about point A is equal to 0. Our sign convention for moment is clockwise moment is taken as positive and anti-clockwise moment is taken as negative. So about point A, first we have an anti-clockwise support couple which is denoted by MA, and since it is anti-clockwise it is minus. Then about point A we have a clockwise moment caused due to this downward UDL of intensity W Newton per meter and acting for a span of L by 3. So we can always assume a point load of magnitude W into L by 3 which is acting at the center of this span BC, that is at a distance of L by 6 from point B or 2L by 3 plus L by 6 from point A. So we have plus W into L by 3 into 2L by 3 plus L by 6. Now this is expression for sum of all the moments about point A and it is equal to 0. So upon solving this we get the value of MA as W into L by 3 into 5L by 6. So this is equal to MA equal to 5WL square by 18. Now since value of MA comes out to be positive, our assumption of MA being anti-clockwise is true. Next we use another static equilibrium equation which is summation of all vertical forces Fy is equal to 0. So now in this beam we consider all the vertical forces. Our sign convention is upward force is taken as positive and downward force is taken as negative. So we see that our first vertical force is this vertical support reaction VA which is upward, so plus VA. Next we have this downward force caused due to this UDL of W Newton per meter acting for a span of L by 3. So we can always assume a point load of magnitude W into L by 3 acting at the center of the span. So we have minus W into L by 3. Now summation of all this vertical force is equal to 0. So from this we get the value of VA as W into L by 3. Since the value is positive, our assumption is true, that is VA is acting upward. Now let us move towards shear force calculation and bending moment calculation. So shear force calculation. Now we take point A as origin and we move towards right towards other extreme end point C. So we first take a section towards right of A and very near to it. So shear force towards right of A is equal to, our sign convention for shear force calculation is upward force on the left hand side of section and downward force on the right hand side of section is taken as positive, whereas downward force on the left hand side of section and upward force on the right hand side of section is taken as negative. So now, considering the left hand side of section, we see that there is an upward force which is VA of magnitude WL by 3. So shear force towards right of A is equal to WL by 3, and this will be positive.